It's just so nice coming and meeting everybody and making connections with people and actually having a sit-down conversation with them, getting contact information and just kind of being seeped in the environment of a bunch of really intelligent, really driven developers. I mean, it's awesome.
So, dependency injection in C++. That's the name of the talk. I'm in Bloomberg. I've been in Bloomberg for a while. If you have questions, and you can shout up some questions or you can come up at the end. But if you notice the slide number down here when you're talking about something, we can get there quickly. I don't expect to have much time at the end. So who am I? A little introduction. All right, my name is Pete Muldoon. I started using C++ about 33 odd years ago. My professional career has been mostly in system analysis and architecture. I did 21 years as a consultant, which just means I was in a lot of places, seen a lot of different stuff, so very wide ecosystems I've seen. And for the last decade plus, I've been in Bloomberg, and I'm currently a Bloomberg ticker plant engineering lead. And when I come to conferences, what do I like to do? Well, I like to take talks that are practical. They're based in the real world, because it's mostly where I program. I try and demonstrate applied principles of structured programming. And hopefully you take something away, or you take a different way of thinking about things back to your work on Monday morning, okay? So where will we be going in this talk? Well, this talk will be about meaningful dependency injection. And I will talk about that later, because there's lots of very horrible things done in the name of dependency injection, and we'll try and avoid those. We're going to use various dependency injection methods to achieve functionality swapping, mainly for unit testing, but you can use it to make the same code do different things, but that's less used. And we're going to focus on the strategies or how you think to get DI into your code that you may not have planned from the beginning, or you're coming into a code base that has not been set up to give you it, and without doing an undo, what I call warping of code. So your code starts looking really, really strange just so you can test it. All right, and as I say, this talk is rooted in a real world. I've been doing this for the last 3 or 4 months in a really large code base inside of Bloomberg. So it's all kind of lessons I've come across. So what is dependency injection? I say it decreases the coupling between functionality blocks. And if you need dependency injection, it usually forces you to take pieces of functionality and set them apart. Okay, so that's one. Second, it's used to make class or functionality that's in classes or functions independent of their underlying dependencies. So you're able to inject functionality into other classes and functions. This all goes to improve the reusability and so the testability of the class, because one way you reuse a class is to test it. And the last thing is we've better long-term maintainability of the code. The code is usually easier to work with. When it's tested, it's more reliable, and you're more confident when you make a change that you haven't broken something. So let's talk testing without dependency injection, all right, which is where the code base I was in originally started out. So we do what I call pocket universe testing. What does that mean? Well, we set up, usually in a unit test directory, right, a fully, barely functional environment where your whole test is brought up. So you've got toy databases, maybe a toy server or router to play with, and you get this full environment up, all right? But when you do testing of this, it's integration testing. And although integration testing has a place, it doesn't take the place of unit testing. And when you can't unit test, you have these problems where you get a bug or you have bad functionality. You have a lack of specificity. What do I mean by that? It's like, I don't know if you've seen the Aliens movie where they have the tracker, and it's like they're coming, they're 10 meters away, they're 5, but they're right on top of us, man. And they don't know where it is because it's right up here, right? So when you have a bug show up in unit testing, it's usually easier to find. If it's in a system-wide test, you don't know whereabouts the system is breaking, all right? So you have more difficult setup and error investigation. The feedback loop is generally longer. If I make a change and I want to test, does it work? And I've got to check in a PR, have the CI system run. That's a longer feedback loop. It slows down your velocity of getting features into production. And lots of times it leans entirely on testing that the same thing is the same. All right, what I call real post conditions. So what is the essence of dependency injection, right? What is the meat of dependency injection? It's to do with an interface. Now, we have an interface, and on one side someone's using it, and on the other side we have an implementation. And we want to say we don't want to engage all that implementation, so we put data into the interface. And what we do is we can capture that data if we have dependency injection. So something that's taking a lot of data and hitting some component, we capture that data. And instead of having to go to a database or go to a cache or something, we can just synthesize data and send it back and make sure we get the proper results back. So that's what we're trying to do with dependency injection. And what we don't want is side effects. I don't want to do a test and mess up a real database, right? Or have to connect. I had one time a group call me up and say, you've taken down the dev server. I was making code changes to it. And I said, well, why do you need it up? It's like our unit tests don't work without it, right? So whatever unit test they had, it needed a real server up. That's something you're supposed to catch with dependency injection. So let's talk about your system. How do you look at your system through dependency injection? Well, the first thing you look is what is the things that carry the data around in your system? The data holders. For me, it's things like brokers, trades, securities, permissions, stuff like this. And these things can be used as dependency injection points into your system for what I call base or core functionality. Here I have it where I'm figuring out pricing, or I'm figuring out the sizing of a trade or an order, or I'm going to send it or send it somewhere down to the SEC. These base implementations now act as component dependency injection points into large parts of your functionality, actually do real operations. So here I have cancel trade, execute trade, reprice trade. So these are all dependency injection points as you build your way up, which you must start at the bottom. If you try and jump in the middle, bad things happen. All right, so let's first talk about basics, even though a lot of you probably know this. Some of the basics of dependency injection is the methods. So linking is a form of dependency injection. So how does that work? I was talking to someone yesterday and I'm very surprised we use this. So link time switching of functionality means that you have some different CPP file with no functionality or very little functionality in it, so you don't drag in, right, all the regular functionality. And that allows limited testing. It's sort of one test scenario per link. It doesn't, the thing it does is it does not contaminate your production code. So you don't need to put hooks in, you don't need to put extra parameters into functions. You just swap out a different .o file when you link. All right, and this thing is externally injected. The application has no idea what's going on, right? Because you've injected it either with a new lib path, so you pick some dummy library out, all right, or you have an if-def test, right? We compile it up for a test. So what's the problems with this? Well, it looks something like this. We're going to have one set of code for production, which has real functionality with all of the real dependencies in it. And we're going to have another CPP file with all that functionality just for test cases. All right, it's an alternate implementation. And when you do one link, you get one set of testing scenarios. All right, so what does that look like? Well, here I have an action handler, and here is the dependency I want to try and get my hands on. All right, this comms. So what I do is I say, look, in the real test, when I'm doing comms, I've got to contact the router, I've got to establish who I am, I've got to say, when I send you this, this is the place you're going to send it back to. But when I do my test, I have a test directory off with a com.cpp, and I put something simple in it like this. I just want to capture the request. I capture it here in some external global variable. All right, and now in my test, I can check what the request looked like. All right, so what are the drawbacks of doing this? And I've come across a lot of this in older code bases, and the drawbacks are the logistics of doing unit testing on many components become impractical, unmanageable. Imagine you have to have all these different makes to get your individual testing done. You also get a lot of undefined behavior and ODR violations because you haven't done enough mocking of this dummy functionality, right? Or it tries to pull both in. What we had happen one time is the mock version made it into production, right? We caught it before more or less anyone else caught it, but that's one of the problems, right? And it's more like integration testing. It's not really unit testing, all right? So it's not developer friendly. It's brittle and confusing. So my recommendation is don't use this. And if you feel like you have to use it, get up, walk around, come back down, and then don't use it. All right? And if you do that, it's still call your friends over and say, tell me not to use this, right? Shouldn't use this. It is short-term gain for a lot of long-term pain. All right? So that's linking. That's off the table. All right, so what about inheritance and virtual functions, right? That's another way of injecting functionality. So we create a base class interface, or we extend from an existing class. This can handle lots of methods, or it's got a rich interface. It's a well-understood mechanism. It's been there since day one. All right, we've had, well, virtual functions since day one, and override since CPP 11, which is 13 years ago, so it's well established by now. And it's easier to add to older code bases. Legacy code bases tend to be built up on a lot of inheritance. All right, anything that's over 10 years old, I'll say, is probably just completely inheritance-based. So how does that look? Well, here I have a calc engine which has a couple of virtual functions in it. And I have some function that's called process that's going to take this calc engine, it's going to run some functions on it, right, to get my business done. So here's where we're going to test. And here's where we have the injection into our function. All right, nice and clean. And all I do is I derive off test calc engine, or drive off calc engine a test calc. And all I put in this is override functions which are going to have just the functionality I want to have. That's going to capture anyone trying to go to some place I don't want to go, outside of that small pocket of code I'm trying to test. All right. So the other way you can do this, of course, is you can say, listen, I'm going to have an interface class instead. So we have pure virtual class that's got an interface. And we say, now anything that derives off that is what we're going to use. The test calc engine can be dropped in your tests and make sure we don't pull in all these extra dependencies or have what we call undesirable side effects, okay? And I use gmock. I've used some catch, but I generally use gmock where I am in Bloomberg. And as you see there, we just take the test calc and we just make it into a mock class with mock methods. All I'm saying is, look, I have a method that's called execute, returns a bool, takes some stuff, 3 dots, and is an override function. Okay. So is there any drawbacks to inheritance? All right. There are a few. All right. The interface, because it can be so rich, can be also very messy. All right. Because it's messy, people can slip a lot of stuff in there, right? I've seen in interfaces functions that says, this is a test function, don't use in production. Right. And you know that comment probably doesn't carry the rule of law with it, right? It might make it into production. Right, you also get then data mixed in. So people say, you know, I'll put some protected data in there as well, just for convenience sake. And then it uses virtual function table, which means there's technically one extra hop. And anyone who's in the I hate virtual functions camp says, look, this extra hop will kill you. Right? I have large buckets of latency, and the steam coming off it is not even the virtual function hop. Right? So it's not something I really worry about. So that's inheritance as a dependency injection mechanism. Anyone, any questions? All right, cool. Templates, all right? So if you're using inheritance, you're part of the old school, you're not very cool, all right? You want to move to templates. It's more complicated, so it looks cooler. So you create a class that satisfies the calls that are made on that piece of injected functionality. And it also can handle lots of methods, so that's great. But we only need to define the methods we actually need. In the last slide, I forgot to mention, I had a pure virtual interface where I needed to mock one method, so I made a new class, and there was 165 of the pure virtual functions, right? So that's sort of what the problems you get with the messy interface, right? But here, we only need to define the functions actually being used. It's compile time, so you have no virtual function hopping overhead. Right? And it can use the concepts in C++20, which allows us to define sort of an interface for our templates. So what is that going to look like? Same function, except this time we're passing it as a template parameter. All that we have is we have the dependency here, engine.apply, and here's where I'm injecting it. All right, very neat. And then in production, production code will have a real calc engine pushed in the main application. And in my unit test, I'm going to have this test calc engine, which is going to have these 2 methods on it. All right. So it more or less acts somewhat like the inheritance. It just gets rid of the virtual functions. Now, you can also mock these classes out, right? And we just put them in. But since we've come through C++20, we now have the idea of concepts. So instead of having some free-form class in there, and look, if I put any class in there that's missing the apply function, I'm going to get 20 pages of messages telling me I've messed up. All right, but with concepts, we're able to say more definitively what our intent is. So now we have a calc engine T as the template parameter. All right, and the messages we get back is much easier to work with. So that can handle lots of methods. Compile time, what are the drawbacks of templates? Surely there is no drawbacks with using templates, all right? Well, there is, right? When you bring it into an older code base and you bring in templates, like a kind of poisoning, templates have to go all the way down. Now you can mitigate that to some degree with ctad and helper functions, but it only gets you so far, all right? You get increased compilation times potentially. I don't worry too much about that. But overall, it can be more hieroglyphical. Right? Templates are definitely harder to read. And that's templates. Everyone with me? Yeah? Lots of nodding heads in YouTube land. All right. So let's talk about type erasure. One of my favorites came along in C++11. What I can do, well, anything that satisfies a function signature. So I'm going to give you these parameters, and I'm going to get this return value. I don't care where you get it from, how you get it, just take my parameters and put it back. That's std function. Move only function is later in the standard, and invoke. It's invocable on any callable target. It means if you can call it and get with these parameters and get the stuff back, we're good. It's versatile. It's really versatile. And that means I can chain it with other methods of dependency injection. So how does that look? Well, here we have a dependency type called calculate yield, right? It's going to be functionality going to inject into my yield processor, all right? But I'm going to capture the dependency in the structure here, and I'm going to inject it here in the constructor, okay? And this allows me now to change what the yield calculation is. So it doesn't have to be just for test. Potentially, I can be putting other stuff in there. And here's where we actually exercise the functionality. So dependency injection, as I'm doing today, is mostly related to unit tests, but I don't have time to go through tons and tons of unit tests. You should have gone to back to basics of unit testing the other day if you wanted that. My good friend Dave here, but here's one. So I have a test. I want to test the yield processor. All right, so I'm going to pass in my own simple function to calculate yield. I'm not trying to calculate the yield calculator. I'm trying to test the yield processor. So I'm going to put in a really simple function, which just gets me 1/10 of whatever the value is. That's one of my preconditions. I'm going to inject it here, and then I'm going to actually do the testing. And once I call this, I know 100 by 0.1 is 1, and here I can do my post-condition testing. All right, so this is just all of the dependency injection will go to something like this. So what's the problems or drawbacks with this? Well, it can handle only one method being substituted. Right, so if I have 5 functions need to be called, I got to put 5 of these in the class. You know, in the end, people start trying to put collections of it, but that's just a virtual function table, right? So go back to inheritance if you try and think, if you get more than 1 or 2 of these in your class. It's got a similar overhead because we have with the type erasure, we got to do that extra jump. But overall, it's not too bad, and I like it. We're going to see why. Any questions? So there are the 4 methods of dependency injection. Anyone, any questions? All right, cool. So I just want to take a minute to talk about null value objects. And what's a null valued object? It's a stub which has no functionality. It only satisfies the type requirements on the function call. Right, so what it's used is to disable parts of a system you're interested in testing right now. So it supplies the correct type, but discards all the arguments and returns a fixed value. An example of that would be I have a DB interface, which has the normal commit rollback statement operations, and I have a process that takes this interface in and uses the apply and commit. But I'm doing testing, and I don't need to test the database. I'm trying to test the results. I switch it off by deriving myself off a NullDB class, which just has these very simple functions, which essentially says don't do anything. All right, and then when I do this, I've disabled all the database stuff. So that stops undesirable side effects like me trying to write to a database in my unit testing. All right, that's all I'm going to say about the dependency injection basics. On methods, anyone got any bad feelings about this? All right, good. All right, let's talk about a function. So I have a function here, takes an action and some other stuff. It's called execute. And inside there's a communication piece. And it takes all the data that's coming in, maybe it's some data itself that it gets from somewhere, and it creates this request that it's going to send down. For me, it's sending a request down to a broker. All right, how do I get my hands on the request? Because if I do a test in a unit test where I say, I put this action in, I got this result back, and the result just says true, or the return code means great, but what did I actually send down in the request, right? I send something down, the broker then is all over me because I sent something bad down. So I need to get at this stuff, which is what dependency injection also helps you do. Let's talk about types of dependency injection. Right, so you have setter dependency, or I think they call it property dependency injection. And that looks something like this. I have a class where I have a dependency. Here it's a unique pointer of my comms class. All right, and here's where I exercise it. And I don't actually want to send it down to the broker. I have to set up a real communications infrastructure in my unit testing. So what I do is I say, look, have a set sender. It's great, right? So I haven't touched any interface. Execute's still the same. So what are the problems I get with this? Well, actually, there's the injection now, right? But what problems do we get when we do something like this? Right? The signatures have not changed, which is great. And this is one thing that people say to me when I go, this may be not the best thing to do, is that the class spends time in an unusable state. So if someone does not call that set sender or gets somehow left out, what am I going to throw an exception? It may bring your application down, at least bin that piece of work, right? Drop it. So that's the problem with setter injection. And because of that, right, I'm going to say, don't use it. Right? And these set functions are generally not used in production because we're so scared someone won't set it. It becomes a test-only function. We've added something on there that says, so the constructor puts one of these unique pointers where the comms in, and when I do the set, I just change it out. Now I have poor class invariance. I don't know what actual comms was in there at the time. I got to figure that out as well. All right, so just don't use it. All right, so take that off the table. Just like linking, it's off the table. All right, let's talk method injection. All right, so here we have that same function. I'm going to just directly drop the comm in. It's very honest. Right, you can see what's going on. You don't have to put something like, there's a hidden comm thing on here that we're using. All right, and the function, again, the function signature look really, really good. What is the problem with this? Can anyone? Come on, you guys you're not on camera. Shout it out. No, it doesn't expose implementation details. It just tells you this is what I'm using. So that's okay. But good attempt. You're at least one of the guys who was able to. Huh? I can't hear you, but I'll assume you say. I'll show you now what it is, right? So I have the execute. All right, here's my dependency, and I'm going to drop it right in here. Right? So there's my injection. What have I done? I got hundreds of people using my execute function. I've just broken all their code. All right? The function signature has changed. All right? And that's when the setter crowd go, aha, I told you we should have used setter dependency injection. I'm like, no, I have a fix for this. All right? But this is one of the things you have to deal with, and especially if it's some external, it's a library you're giving to external groups to use, you're probably not at liberty to do this very easily, right? So method injection has that drawback. And the last one we're going to talk about is constructor injection. So here we have our method injection from before. All right, so we have this execute that's taking the comm function, but just engage me in a little thought experiment here. Assume that was in a class. All right, and assume that the comms doesn't actually change. It's not like we get different comms per execute call. It's an invariant. Well, then why don't I just capture that, all right, down here in the class, and then I'll inject it through the constructor. And when I call the method, it gets injected by the class itself. All right, so this is great. All right, but the function signature is unchanged. And look at the execute. The function hasn't changed, so it's great. We don't break code. But what have we done? I can't hear anybody. I hear vague mutterings. Yes, we changed the constructor, right? We've changed the constructor. I'm back to breaking everybody's code again, right? Where I am, huge numbers of people are using my code, right? So I can't do that. All right, so constructor injection has that drawback. So that's the very, very basics. Now we're going to get into the real world thing. But before we get into real world dependency injection, I want to talk about conceptual dependency injection, right? So we just control all dependencies in a system. And I do that by just identifying some functional blocks, and I just inject that functionality and capture the inputs and control the output data. All right? And all I'm going to do is I'm going to say, well, where do I do that? Look, any place that it's an invariant dependency, push it in the constructor. Everywhere it's something that moves around, I'll put it in the function as a method injection. Boom. Then just add a virtual hop in any class that's in there, that's in your code base, right? Just in case you need to do a dependency injection. So that we have ability to swap it out. This is what I call conceptual dependency injection. It's usually useless in the real world. All right, it codes up bad interfaces, and terrible things are done in the name of dependency injection when you do it this way. People will I have a bunch of static functions. I'll take a class. I'll just name every function on the class the same as that static method. And then all the parameters this take goes in, and it just calls that function. So it's just one extra hop. And it's like, that's dependency injection. It's not, right? That's making you feel better. What happens is you've just coded up probably a really terrible interface. And we'll talk about what that means when we get to more practical stuff. Right, but I got to tell you, the real world starts here. So if you're a theory guy, you're like working in the very foggy edges of the language, we're going to lose you right now. All right, so I'll see you at the end of the talk. Right, so let's talk about dependency injection roadblocks. What goes into code bases that makes them hard to do dependency injection? Or if you go into a legacy code bases, what do you find there that makes it difficult? And that's when people go, you know what, my code is not unit testable. All right, so integration testing is great. All right, and I go, well, it certainly isn't unit testable because you don't have it anywhere designed to be unit tested, but it can be, all right? And this is what we're going to talk about. So if you have an object where its creation is hidden inside a function, and there's no way to get to it, you can't do dependency injection. So what does that look like? So I have a class, and I have a process A on it, and I make a processor, and I put some kind of fixed args in to create it. Right? Other than link time injection, which I told you not to use, there's no way of getting my hands on changing this processor, right? So some stuff like that stops you doing dependency injection. We have other things where we have a process B where we say, look, instead of doing something like that, let's go to our singleton, our trusty singleton pattern. I wrote a talk about why not to do this. And we'll just get the processor. Who thinks this is a good idea, the better one on the bottom? Come on, there's some of you out there. Oh, this guy, okay. All right, it's a terrible idea. However, but most times we don't call them singletons anymore. We call them factories, right? And now it's nice. We just have object factories, class factories. It's great. They're not a singleton anymore. However, it turns out there's only one of them, and it's a global data, and it gets injected in this way, right? So this is stuff that stops you doing dependency injection. So don't do it. All right, reaching through multiple objects is another way of doing it. All right, what does that mean? Well, we have long chains of classes need to be called, and we break what's called the principle of least knowledge. And that usually means you're handling big grab bags of state around. All right, so what does this is an actual real line of code. All right, if you think I put this together just to be ridiculous, this is a real line of code. So when I want to get this thing called a tick helper, I have this updater class. I call it processing context. It gives me some class. What I call exchanges as class. I have to do a get on something, and again I get a tick helper at the bottom, right? Think if I want to mock this out, what I've got to do. If I put like a mock updater in here, all right? The spaghetti and the hoops I'll have to jump through, right? You don't do stuff like this, right? You only talk to your immediate friends, only the things you need to know. This should just be talking to the tick helper, which means just send it into the function like this, all right? So, don't be reaching through multiple objects. Just pass in the stuff you need so people can see, when they see the function, what's actually being used, not some big bag of something they're guessing what's being used. All right, next, disentangling, getting information from setting state, getting or calculating stuff from state. In other words, dig the pure functions out of your code. What does that mean? Again, real code. All right, this is the thing that says, look, I'm looking for bid and ask price, and I've got it at various degrees of precision. And it says, look, if I get it as this decimal price, which seems a big long number, I'm going to set it. Otherwise, I'm going to get it as a double. Otherwise, as a float. All right, this is all the getting and setting entangled. When I try and unit test something like this, it becomes very possible I'm mutating state of the class all the time just to try and do something, right? And my tests will start looking like one depends on the other. In reality, just separate the stuff out. All right, here's what I did in this class, and then I actually did further, it like went away completely, but right, look, get the price. That's an idempotent stateless operation, just calculation and working on figures. All right, I can call that 100 times, doesn't do any state change, which means that it's good for unit testing purposes. All right, same with the ask price. Next thing, having too many dependencies, and this is the one that's the big one, right? So we've written classes, and especially if you don't have unit testings being written with your code, there's nothing to stop you writing big, huge classes, putting all kinds of stuff together for convenience. All right, and that's why Tony Van Eyre talks about complecting. We just throw stuff in there. It's a class. What's the problem? All right, so what does that look like? Well, here's a function that's got a lot of stuff being passed into it. And I want a dependency injection. People said, this is an unreasonable amount of stuff for me to be doing for dependency injection. So what they do is they say, look, let me just put it into my bucket, all this dumping ground of states and classes and stuff. And now I've got a bucket to put in, right? Is this the way to solve this problem of too many parameters being pushed in? There's a lot of shaking heads, right? No, it's not, right? All you've done is you've moved the problem into the bucket, and I got a God bucket for my God class, right? I don't know what in this bucket is being used. I have to set everything up in it because most of it is going to be references, all right? And I'm not going to have a bucket per function. I've never seen that happen. So there's going to be lots of extra stuff that's not used. So you have to guess and do code inspection again, right? So don't do that, all right? I will say one note that if it's actually coupled data, so it's 4 points of a rectangle, it's all the pricing to do with a security, they can all go into a data structure, right? Because they're related and should be kept into one thing, right? As opposed to a comma or a comment, 4 things, a space, a comment, another 4 things, right? They should be all, that's how we group them together, right? Textually. So that's a problem. We'll look at that in a minute, right? We have other classes or class hierarchies, and this is something I got hit particularly with, that have huge chunks of very diverse functionality in it, right? I call them a God class, because they just do everything. They're omnipotent. They have all the state in them. They can do everything. You just can't do any testing on them, all right? That's the drawbacks. But there are many, many dependencies that are too numerous to inject. I can't say the constructor needs 52 dependencies, right? 10 of which are just floats or something like this, right? So how do we get by that? So let's talk about refactoring for DI, right? So what we have is a godlike class, and this is something this is like based on a real world scenario I had, where I have all these different pieces of functionality in to figure out like what to do my business logic. I got stuff, I got to verify who people are, pricing stuff, I got sizing, what actions I can take, rules, business logic, all this stuff is all in the class. And look, it gives me the right answer at the end. I call the function do everything. It comes out with everything is done, result, right? But I can't do any testing on this. Right? I can't do any unit testing because there's too many dependencies and too much state I would have to take notice of. But what if I take this code, I don't do anything other than move it out? All right, even if it's across an inheritance hierarchy, you've seen that get price function. I move the get price of all the inherited classes out. So I push this functionality out, and I wrap it in a class. You can wrap it in a function if you're a functional crowd, all right? But you wrap it in a class, and I haven't done anything to code, but it still works, right? My integration test still works. But now what I can do with these individual pieces of functionality, right, is I can start writing unit tests. I only have to write it for pricing. All right, it's probably mostly pure functions. Once I do that unit test and I write, and it's critical you do it this way. Once you write all these unit tests, then you refactor the code. Because lots of times when you put all the code into one spot, you see where a lot of duplication and silliness goes on. All right, and that is a prelude to doing dependency injection, because when I look at this now, you still see The God class here has, what, 8 function calls going out of it. All right, so it's a pretty, what I call a wide interface. Right, but if I squint and look at this in a particular way, I can see there's another abstraction sitting here, which is that there is some of these things that are to do with gathering information, what I call like almost a pre-processing of getting my trade together. Then I have business logic, which is to do with accessing the rules upon business logic, verifying you can do this kind of trade or make this data change. And then there's distribution where I send it out, right? I send it out in the Bloomberg terminal, or we save it into our database. And I see that it's in 3 separate chunks. So this is a higher level abstraction. I wrap these things in these new classes, right? So I have an information gathering class, a business logic class, a distribution class. And what I find is when I do that, I can start moving all of that glue logic that was saying, when you get the pricing, if it's this way, then look at this actions, then do this sizing. A bunch of the glue that was in your godlike class moves into those classes as well. So your class becomes simpler. All right? And these classes are now also available for unit testing, except you can inject mock pricing, mock sizing, mock actions in, right? And make sure you're getting the proper data. Because that's the data you're going to be feeding into your main business logic class, or sorry, your implementation class. All right? So what happens is these now just become 3 classes in here. So I don't have 15 classes running around. I have classes in here now that do various work. And when I look at my code, it's easy to see. Here I'm in the gathering information. Here I'm getting logic, applying logic. And here I'm distributing my side effects. And I also then have a class, or the gather information class. That is a dependency injection point to my marshalling class. All right, so that I can put in a mock gather information to test my marshalling class. My gather information class can be tested by the pricing, sizing, and actions being injected in. And then these classes at the very bottom, which are the very lowest components, they have raw pricing, adjustments, aggregate, all the stuff that they need. I can test them exhaustively, happy and unhappy path testing. All right, so what I have is a tiered layer of dependency injection. And I don't have, I mean, if you remember, I had, I don't know, 10 or 12 of these things flowing around. Let's say they all have 3 to 5 parameters of dependency. If I want to push them all in, if I want to do dependency injection, I got to get 15, 20 parameters in. Here I'm able to test each piece in, right, as it goes up the tree of data abstraction. Damn, time's going quick. All right, and then there's the other thing we get is functionality being splintered. All right, so here I have a class that says I need to verify. I'm calling into all these utility classes, and I've got 4 function calls. Right, trying to figure out what's going on or test this is going to be difficult. But if I do something like this, where I say, look, I'm going to take these functionality pieces, because they should be grouped together. Someone just didn't bother grouping them. And I wrap it in a component. Look what happens in my application class. I now have 1 call. I've tightened that interface down. All right, and I can use something like a stud function to do dependency injection now. All right, and these things are also open for unit testing. Write that first, then do the refactoring, and you now have dependency injection throughout your class hierarchies. That's what's refactoring, right, to make things easy to work with instead of putting big gobs of state around. And last, and I just have to squeeze it into the very bottom, is there's this thing called a data structure. So when we have classes, all right, and actually let me show you this class here, right? Here's the class. And I go, well, this only takes 1 parameter. So it's a pretty tight function, all right? No, it's taking bunches and bunches of data just lying around inside of the class. And I find that when I try and push functionality out of these classes, people have just dropped individual pieces of data in the protected or private area because it's convenient. And who cares that I have 15 pieces of data in my private area that's been used by this thing here? Well, you care if I did what for the, so I have, so you see the collector here. I have now a class that's derived off it, which is a more complicated set of building this particular artifact, the data info. Well, you'll see that the collector has to start taking a lot of data in, because I've done what I've done before, right? What you just seen in the last, and I've pushed all this out. This used to be code inside of this class. I've pushed it out into a collector, and the collector now has to worry about all this extra information sitting around in the class. Okay, so what do I have to do? Well, if I go to my collector, here's how it looks. right? Because I've done that, I've pushed out this function. Now, this is fully unit testable. Now, anyone see a problem with this class? Would you be happy if I said, here's the class, right? No, everyone's shaking their head, but no one's telling me why. All right, the problems is it's a hard-to-use interface. It's got a lot of parameters in passed, and then they're all weakly typed. What I mean by that is these can all be transposed. All right, I can make some slip and put the bid in with the ask at the local where the regular is. All right, and I got the same thing going on here for the brokers and the same thing going here for the yields. All right, so this is a terrible interface. And this is why you have to do this first to do proper dependency injection, not just jump in and say, look, let's put something with 100 parameters in. All right, so what is the problem here? All right, the problem here is when I look at this, I see there's a lot of parameters that look similar. I see a lot of bid and ask, and I see a lot of optional stuff. So what if I come up here and I say, look, I'm going to have a small type I'm going to create called an optional pair of T. Very simple template. No one should get confused with this. And all I'm going to do is say, look, I'm going to have a side pair, which is these sides. You're going to have a bid side and an ask side, which is all as these things are here. All right. And if I use that and I go and I say, let me look at my function, the collapse down. All right, now I have the same thing I'm going to do for brokers. Brokers are just the same thing on a broker, so I'll do the broker pair. I'll do a yield pair. And what happens now when I put these in, we come down to this. This is a much better interface, right? And not only is it a much better interface, look down here. All right, this is strongly typed now, which means I don't need to put names on them anymore. That's how you know you've got a proper interface. You're not having to name things. You just let the parameters talk for themselves. All right, so look, I'll go back to my code. Here's what I had before. I'm saying now, what I could do is up in the build function is create this temporary data structure that's a side pair, right, and pop it in. But why would I do that? Someone was just, I won't say lazy, but didn't think to do this. Why not just in the data, create these things properly in your data? They should be held like this in the first place. Someone didn't bother because they figure in a class, who cares? I can just reach out and get them. I don't pass them anywhere. They're global within the class scope. All right, and because of that, then I can make simpler calls. But we're not done. Now let's go back here. I still have the sides can be transposed. All right, I don't like that. And when I look at this thing, actually, I look at the data, it's like, I really should have a side info which has both of these side pairs in it. They get passed around a lot together. And then the extra fields in this thing are populated only by these two together. So I come down here and I change my interface to be this. All right? So again, it's tightened up again. Now look at my interface, right? I'm back to strongly typed. I can get rid of all these names. All right? You just is what it is passed in. It's not one version or another. And when I go back to, so now look at my interface. This is much better, right? Round of applause for that? No? Come on, give me a round of applause. Real world stuff. All right, so look. I go back here and I do the same thing. Why didn't someone structure the data in here properly? And I'll just change this to a side. Now look at the comments that were there originally. Right? I don't have to, the comments don't need to be there to say, yeah, this is a sides info, because the code tells you. You express your intent through the code. You can put extra stuff in there. And look at the top. It's a real tight, clean interface. All right, and that is crucial when you're doing dependency injection. And you've seen in the first one where I had all those things, I went from 8 calls down to 1 to get my information. Right? Okay, so let's look. So if these are all the roadblocks, what's the dependency injection highway express when we want to say, like, what should you be doing in your code so you don't have these problems? Number 1, object creation is done outside of the logic of your functions. And by outside, I don't mean that, you do it and you pass them in the whole time. You can pass in the dependencies directly, or you can pass in the dependency supplier, which we'll talk about in a minute. You should invoke methods on immediate objects. I hope I don't have to explain that one too much. Disentangle the setting and getting from information. That's just good code design anyhow. I mean, it just really bites you if you try and do dependency injection. Refactor your God classes, cluster that functionality, push it out and cluster it up. All right, that lessens the dependencies, refactor fragmented stuff where it's in utility classes, pull it together. We're going to lessen dependencies that way. Refactor data, in other words, look in classes and see what data structures are missing. All right, and you'll notice a theme here. I've been told I don't pronounce my H's right, so a theme here. All right, look, there's all of this going on, right? It's refactor, refactor, refactor. Not rewrite, locally refactor or re-engineer, and it's mostly to do with just grabbing stuff and pulling it together. All right, so let's talk about legacy code, because that's the beast I work in, right? Code that is, and my definition of legacy code for anyone who wants to know is, it's code that was working in production for actual users, right? It doesn't matter how old it is. It just makes it difficult to change when real people are using it, all right? So the code's not malleable, and we don't like large-scale complex changes coming in. I can't rewrite my whole code base for dependency injection, so I have to be judicious about its use, right? And I got to use tricks, right? Because people want phased and localized changes, right? And like I said, that's going to need tricks. I can't be changing interfaces. So how do I do that? And I'm running low on time. So we have a problem. An API is used all over the place. Right? Can't be changed, but I want to do dependency injection. All right, I want to get at this calc here, right? So I just change it and I add it in here. Broken the interface to my class. But what I can do on this injection point is say, look, I'll put the default. Whatever was going on there originally, I'll just have a default calc set in here. All right, that's one way of doing it. So now the API is the same. The ABI has changed. Right? If you want to keep the ABI the same, you'll change it to where you'll just have the same function. We're going to have this dependency injection, and we have the old function is just a forwarding function. All right? And this allows us not to change the interface on a function. All right, so we have default injection here in your forwarding function. Same thing for constructors, right? I just say, listen, I'm going to put it in a constructor, give it default, or I can just use delegated constructors, where I say, listen, I'm going to insert the default, which is the production way of doing things. Don't default it to the test way of doing things, right? Because I'd rather have production problems in test than test getting into production. You can ask me why later. It's happened. All right, so what do we do in this situation? We say, look, do your default dependency, or do your dependency injection using defaults or forwarding. Okay? So it's transparent. The injection, no one knows you're even doing dependency injection. You can now write a bunch of tests. All right. Now, this came up as a real problem, and right, a lazy initialization, which means the class doesn't actually do anything till you actually exercise some piece of its functionality. It looked at something like this. This is the real world class. And you can see here, I have a dependency that's called this DB helper function. And I have this lazy initialization where I say, look, if I try and call this apply function, ensure I have a DB helper. But it's quite expensive. So if I'm just passing this thing through, I don't want you to go get the, I don't want you to get the data. All right, and this create DB helper actually went to embrace the singletons behind the scenes, right? So the first way that it was seen, and I didn't do this, but one of my colleagues just was like, let's just do constructed dependency injection. It's great, right? This is it's how we should be doing it. All right, and because I'm doing this thing here where I'm initializing the helper in my constructor, I can get rid of all this nonsense to do with lazy injection. All right, and then I can just check this code in. Any problems with this? No? This looks good for you? I get this past a code review? It's not lazy anymore, right? I got to take a huge hit when I push this into production, right? Hopefully my integration testing will catch it, right? So the next thing was, okay, we can't do that. And like I said, the decided next thing to do is just put a setter in. We say, look, here's the setter. And you see something really peculiar in here where it says, if it's not set, then set it to my setter. Otherwise, ignore it. And that's because this becomes a test-only function. I'm worried about someone putting something else in production. So this is not the way to do it either, right? And at the time, I said to them, look, this is not the way to do it. It was like a Thursday evening. Just give me it till tomorrow, and I'll show you how to do it. I think I can do it better. And let's go back to where we were. So here's the lazy object. And what I did is said, look, let me make it a DB, a dependency provider type. That's a stud function. All right, it's going to take a string and it's going to give me back this DB helper. And I'm just going to rewrite the class a little and I'm going to walk you through. So now what I'm doing is I have an extra member that's capturing, right, the dependency provider. And over here, I'm injecting it just like I did before. The default is going to be the create DB helper that was always there. All right, and then down here, I'm going to call it. So what this does now for me now is in test, I can say, look, I'm going to put you in a different function that takes a string and returns some kind of helper, but I'm not going to go to all these singletons and all this state and all this setup that needs to be done. All right? So when you have lazy initialization and you're not able to pass in a constructed object, what do? Use dependency provider. So this thing only gets created when the dependency provider is called, which gives you the lazy initialization. All right? Any questions on that? All right, cool. All right, so another problem I came across, and this is a good one. All right, is I had a class, it was called header, and I had my mock header because I needed to mock this. This is undesirable side effects. So I'm going along and I see it's got a get dividend that I need to mock out, and I put the mock method for get dividend. I come along and I put the set model and I mock the set model. I write some unit tests, I check it in. I come back a little later, more testing, I've pushed more functionality out. I need more mock functionality. I come across this inside of it. How do you mock that one? All right, yeah, it's a problem, right? So what do I put down here? Because templated member functions cannot be virtual. If you want to know why, talk to Alex afterwards, all right? So what did I do? I went and I looked inside the code that was there. All right, so I looked inside of the code here, and I seen that there was a templated version of this and a couple of specializations. Right? And one of the specializations was for the string that I needed. So all I had to do was say, look, actually create it as an actual function and take that templating away. It's just a regular function now. All right, now my mock method is just this. All right? So that's the way you handle that. No, that's not the way you handle it. I was just lucky. I just like I struck. What happens if we had to go through the actual generic function? What would I do? Well, there you have to go back to where it's being used. You have to go to the point of sale now, and you have to say, look, I have this piece here where it's calling that function. I'm going to say, look, what I'm going to do is, again, have a function that's going to take a header and a string. All right, and I'm going to now inject it. Here's the dependency being caught, and I'm going to inject it through the constructor. All right, and I'm going to put as the default way of doing it right here. This is what was done before, header.isType, and that's the thing that's going to get automatically injected in the constructor. So my class is fine now. All right, so and for my test, I can say, look, instead of doing all that hocus pocus, I just pass back the type nums I want to check functionality out. All right. So I gave this as a dry run originally, and the guy, I don't know if he's here, he's the chair of the tooling, said, hey, you didn't actually solve the problem, you waltzed your way around it. What happens if I have lots of different types being passed in that class? And I said, oh, you mean if the class looks something like this? So all that stud function nonsense you're using can't be used anymore. Is there any way to solve this problem? Yeah, there is, right? Here's where we're doing the testing of it. Right? I've crossed over into template dependency injection. Right? Recognize when you've gone over the barrier. All right? I don't need to use virtual anymore. Right, here's my injection through the header. And all as I do down here is in my mock now, is I just actually put it in here, and that mock's going to be dropped in wholesale. So what do you do for something like this where you have virtual and templating crossing over? Well, you can turn it into a regular function if you're extremely lucky, like I was. You can do it for limited types. You can add type erasure. All right, or at the end of it, you just move over to template DI. That's what you've got to do. All right, and it shouldn't be too bad because you've been forced that way anyway. Like there's templates all the way down to you now, so you just have to put your templating in. All right. So let's talk about DI myths, right? People said dependency injection is simple, or only for simplistic systems. It is simple when you're doing little toy programs. All right. In the real world, it's really hard to do, and that's why people tend to shy away from it. All right. Some people, it's overkill on smaller projects, right? It's too small for testing and dependency injection. Yeah, that thing's never going to get bigger. All right. It's only for testing. It is primarily used for testing, but it is not only used for testing. You can take the same piece of code and have it do different things. And when you have dependency injection, oh, wow, we're doing something else, a new requirement. Let's drop a different version of this in and not have to rewrite a whole bunch of functionality. Right, and the other one is forget for now. It's easy to add in later. That's a real porky pie. All right. So what are the dependency injection truths? What is the truth about dependency injection? All right, it's hard for real production systems. And you have to use techniques like this. I'm not talking about little functions where you have a car, you drop an engine in. I'm talking about big systems. All right. Properly factored code is the ultimate key. You've seen it there. Dependency injection needs you to refactor, not rewrite. Refactor, move your code around a bit. All right. And you must give weight to that local refactoring when you're, like that extra time when you're planning with the work you're doing. I'll need to do some refactoring here, not just make a change. And poorly formed code, aka legacy code, aka code that might have been wrote last week but checked in by someone, needs many tricks for DI. And that's going to make your code reusable, testable, and you get to sleep at night because you have better long-term maintainability of the code. So what is the revelation? What am I trying to bring to the table here? What do you take away from this talk? What is it? Go up the mountain, I come down with the tablets. All right. It comes down to you lessen the number of dependencies, right, in the layers of your functionality, right? And that means you have to take things and do what I call a horizontal abstraction, which means completely different stuff goes into completely different areas, right? That's so you refactor them into decoupled functional blocks. And the vertical abstraction is that tiered layers, which is what I showed you where you have the base functionality as dependency injection into component, into the marshalling. That's what we call a vertical abstraction. Again, lessens functionality. All right. And that, my friends, is the end. All right. I only have an hour for this. I could do probably a half day on it. So thank you. Here's Godbolt listings, if anyone wants to go and see how it actually, under the hood. And here's other what I call engineering talks, meaning it's practical. And let's take questions. I have 2 minutes, 20 seconds. Yes, Dave.
Thanks, Pete. That was cool. I'm glad my aliens analogies are taking off and they've got some legs to them. What do you think about the possibility of asking the teams that are building the things that you need to dependency inject to build you the mocks, or to arrange for their thing to be easily mocked or dependency injected?
Yeah, I mean, you can always ask, right? And it's nice if they do it. I find that the people who wrote the code are dead or gone, right? And it comes down to, look, when it's, like, oh, everybody in the team should be doing this, right? And if nobody's doing it, nobody cares, right? So, but what I have found is that when you show people, look, taking a piece of code and breaking it down into functional blocks, writing tests on it, right? Collapsing the interfaces down and putting that back in, they find that like kind of cool thing to do, all right? And I think if you try that, I won't say at home, at work, try that at work, you'll find that like this is kind of neat and doesn't add that much on. It's a learnable skill, but you need to learn it. Andreas.
Yeah, thank you. That was a very nice talk. One thing that I noticed, like when you were mentioning as a blocker, this reaching through objects, where you had this very large line, and then you had to go from one object to the other. When I'm doing like breaking the God object down into like this tiered layer, ain't I building something exactly like this? Like, isn't there a conflict between the two?
Between not reaching through bunches of objects? No, because the tiered layers are just getting what they need. Right?
Okay, so that's the crucial point here, that if I'm reaching through, then I've actually passed in too much that
Right.
is not related.
Right. Now, the piece above it, let's just say, is being somewhat naughty, reaches through a bunch of objects to give you that tick helper. But so what, right? You're getting the data coming out of what's been pushed into that. And when you go to replace that piece, all that stuff goes away anyway, because now you're directly injecting to the higher level of abstraction. So that's how you get away from that.
Thank you.
Okay. I think I'll take one more. I see I'm over.
Maybe a basic question, but I was just wondering what would be the disadvantages of method injection, wherein, yes, you're changing the function signature, but the second argument can be like an optional or a defaulted value, wherein, and you can go ahead and make it a variant which takes in just an instance.
If you're a functional programmer, method injection is the way to go. All right, because you don't have classes, right? Then you'll just have a bag of state you pass around. The problem is like, why not just pass everything in through the function method? Is there's lots of pieces that are invariant in a function, right? That'll always be the same, and that's why, you know, data plus object, data plus functionalities, classes, we put those in there in a place that's hidden. And the other thing I forgot to mention is, you see when I drop these interfaces down to one call, it means those calls are going on behind the scene, but now I'm free to refactor those. Because, again, another advantage of shrinking that interface down for the dependency injection. All right?
Thank you.
All right, thank you. We're out of time.